Hello everyone, my name is Tim Lulu Afuakwe and I will be discussing on the ordinary regression assignment question 2 solution. And this is question 2. So this is the table from the clean table from question 1, and it has here's the sum of the squared residual, which is 4.8. Take note of that value. Then so the first step, we are looking at increasing the intercept by 20%. So this is the equation from the first question. So an increase by 20% is calculated as 1.84. The intercept is calculated as 11.04. Imputing 11.04 into the equation and solving for y gives you this predicted value for y. The residual is calculated by subtracting predicted y from observed y. Then the residual, the sum of the squared residual gives 21.73 for this specific line. Then calculating for a decrease in intercept by 20%, you get 7.36, and the predicted y is gotten from this equation, and the sum of the squared residual gives a total sum of 21.79. Comparing the three lines, the normal line and the line equation from question 1 as a clean table, you see that it has the least squared residual of 4.8 compared to the others, which are 21.79 and 21.73 respectively. Then plotting the Excel, the chart, you have to combine the three tables, table 1's x and y values, then the y predicted value from increased by 20%, y in predicted value from a decrease by 20%, respectively, for the intercept. So you go to the insert portion of Excel, then click on the scatter plot, and this appears, the scatter plot appears. Then the next thing is to highlight on each of the points on the scatter plot to add a trend line. In formatting the trend line, after formatting the trend line and adding the labels, you have this plot, and this shows the red line shows an increase by 20% in the intercept. The normal line that doesn't have any increment or decrease in intercept, while the green line shows the intercept that has been reduced by 20%. Then the next thing is to increase the slope by 20%. And the 20% of the slope is 0.16. And the equation turns out to, increase the slope by 20%. So that will be 0.8 plus 0.16. That gives you 0.96. Then on adding that into the table gives the squared residual to be 6.22. Next is decreasing the slope by 20%. That will give 0.64. And the sum squared residual from after doing the necessary calculations is 6.21. And finally, this is the chart from the changes in the slope and the normal regression line that doesn't have any change to the slope. In summary, the line the equation from the first from question 1 has the least squared residual compared to the other two lines that had adjusted slopes, and that's 4.8. Thank you very much.